Welcome to the Walton Pi. Today we're going to go through a pretty tricky problem where we are going to go through and prove Snell's law. So what is Snell's law? Well, what it says is if we have some water that goes like this and we have light coming in at a certain angle, and this angle is going to be measured right here with theta 1, it's going to then refract and come out at a different angle here. And this angle over here is going to be theta 2. And these angles correspond to what the velocity of light is in those different spots. So here the velocity of light is going to be v1. So this is the velocity of light in air. And then down here we have v2 is going to be the velocity of light in this substance. But in both of these cases, the velocity of light is going to be a fixed constant. So throughout this entire problem, everywhere where it's a constant, I am going to be writing it in red. And then anything that's a variable, those are going to be written in a different color. So what is Snell's law? Well, what we are trying to prove is we are going to try and prove that sine of theta 1 divided by sine of theta 2 is equal to v1 over v2. That's going to be our end goal. So let's go and try and set up a problem to be able to solve this. So let's draw out this triangle one more time, and we are going to go through the pieces as we are going to set them up. So we have the following. Comes in at this angle, it comes out here, goes up, that's a right angle, that's a right angle. Now, the real question is, what are the different things that we can label? Because this is theta 1, here's theta 2, but velocity doesn't really have a place anywhere on the sides of these triangles. Instead, what we're going to want to do is we're going to want to have everything in terms of distances. Those are going to be a lot easier to work with. So, how are we going to scale these? Well, because light's coming in at an angle, light doesn't change its path. So we could actually continue this line backwards and continue this line onwards, and those are going to be perfectly fine. So that means that we can actually scale these triangles however we need. We could move this side in this way, so we start with a smaller triangle, or we could stretch it outwards if we need, which means that these distances are completely arbitrary. So we are going to just pick them to be 1, because that's going to make our lives as easy as possible. Now, how are we going to be able to prove Snell's law? Well, Snell's law is actually a result of minimizing the time to go between point A and point B. So because we're trying to minimize time, we are going to have some function in terms of t. So we got t is equal to something. Well, it's the time it takes to go here, to go in the first spot, and then it's going to be added to the time it takes to go through the second part. So what's the relationship between time and velocity? Well, we know that velocity is equal to distance divided by time. So that means if we want to solve for time, we can find that time is going to be equal to distance divided by velocity, which means that t1 can be written as d1 over velocity 1, where we say that this distance right here is our distance 1, and this will be distance 2. So what we can do now is we now have a way to write our time equation in terms of something else. So what we have is we have time is equal to distance 1 over velocity 1 plus dist 2 divided by velocity 2. Remember, velocity 1 and velocity 2, those are constants. So the only variables currently are d1 and d2, because those might change. So how can we maybe reduce this down to only have one variable? Because d1 and d2, those are two different variables, but there is a relationship between them. So how can we have a nice connection between those? Well, we can give a distance between this entire thing. So let's call that this entire distance is a. Remember, a is still a constant, so maybe I shouldn't have that in blue. but that distance is going to be a constant distance, which means that if we label this side maybe x, then this distance here is going to be a minus x. So now that we have that, we can actually solve for both distance 1 and distance 2 in terms of x. So let's go through and do that real quick. So we have distance 1, let's get a little bit of space. Using the Pythagorean theorem, distance 1 is going to be the square root of 1 squared plus a minus x squared. So that's distance 1, and then distance 2, using the Pythagorean theorem, is the square root of 1 squared plus x squared. So we can now have a function in terms of only x's and constants. So we get t is equal to, and now I'm only going to change my color for the variable. So t is going to be equal to distance 1, square root of 1 plus a minus x squared divided by velocity 1 plus distance 2, square root of 1 plus x squared divided by velocity 2. So we have those, and x is our variable in both of these, so let's change that color. That's not visible. X, x, and then we have a minus x. Okay, squared. So that is our function now in terms of only x's. Everything else is a constant. So now we can actually take the derivative to find the minimum time. So let's go through and do that. So t prime is equal to, well, the 1 over v1, that's a constant, so we can pull that out, times the derivative of the square root. Well, that's a 1 over 2 times the square root of stuff, 1 plus a minus x squared, multiplied by the derivative of the inside. Well, the derivative of the inside, that's a 2 times a minus x to the 1 times a negative 1, plus the derivative of the second one, that's a 1 over v2, that'll stick around, times the derivative of the square root piece. So that's a 1 over 1 over 2 times the square root of 1 plus x squared, times the derivative of the inside, that gives us a 2x. So we can cancel a little bit, we can cancel these 2's. And what do we want this to be? Well, we want this to be equal to 0, because we're looking for a minimum. So when we go through and solve that, that means that we get, if we add this term to the other side, we get 1 over v2 times x over the square root of 1 plus x squared is equal to 1 over v1 times a minus x divided by the square root of 1 plus a minus x squared. And at this point, we might not be thinking that's very helpful. But if we go back to our picture, what is sine of theta 1? Well, sine of theta 1, if we go to the triangle, it's opposite over hypotenuse. Well, opposite over hypotenuse, that's a minus x over the square root of 1 plus a minus x squared. That's this piece right there. And then sine of theta 2, well, that's just x over the square root of 1 plus x squared. So we get that 1 over v2 times sine of theta 2 is equal to 1 over v1 times sine of theta 1. And if we just rearrange these terms a little bit, we get sine of theta 1 over sine of theta 2 is equal to v1 over v2. And we have successfully shown that Snell's law is going to be true. I hope this video was helpful and that it made sense. Please let me know if it didn't, and I will do my best to follow up or reply to your comments. And I hope you all have a great rest of your day, and good luck with the rest of your math.